Hello, ST589, Fundamentals of Information Systems, or IS. This is lecture 12, and this will be a lecture about assignment 3, which is your database assignment, which we're doing in MS Access. I want to make that point because the concepts you learn here could be used in any database. Access is a very small level, small business type of DBMS, database management system, but it has all the functions of a bigger one. It just can't hold as much data, doesn't have as much functionality, but it does the basic things. You can learn all the concepts in this software, this application software, this database management system, this DBMS, then you can take those other places. I think one of the reasons I like doing this assignment is I see so many people using Excel to keep track of their data, and Excel can do it. It just isn't designed to do the kinds of things you need to do with databases, and this database also teaches you the concepts you can take onto other databases like Oracle, big, huge databases, Ingress, you know, those corporate level databases. Well, you can learn enough here to move on to those as long as you're not managing them, but you can certainly get information out of them and put information in with what you learn here, and a little bit of training, of course, on their interface. So that's kind of why I like this assignment. I think people should use Access to store their data and retrieve their data. It does a lot of things easier than Excel could do. Could you do everything you do in Access in Excel? Of course. But it's much more difficult, and the data is harder to share and those kinds of things. So let's take a look. And before we do get into the assignment itself, let's review a couple of terms we went over in the lecture on databases, which I believe was lecture 10. And we're going to just have a quick review here. Originally, we had file systems. And human resources had a file. Payroll had a file. Marketing had a file, or files. Production had a file. Shipping had a file. And everybody was happy with that because it was better than keeping stuff on a piece of paper in a drawer. And when they had paper in a drawer, of course, they couldn't share it either. But in this, for old file systems, they couldn't share it. Somebody came up with the idea of, what we have here is we have a customer here, perhaps. Customer here, we have customer here, customer here, customer here, or employee here. You get the idea, employee here, employee here, employee. We have the same information in each location. Do you think that information agreed? Of course not. Whenever you have more than one copy of anything, they don't agree. That's by definition. Even if you use a Xerox machine to copy it, somebody's going to start writing on it, changing it, and then copying their copy, and so forth. It's never the same. The classic example we use is when a woman chooses to change her name when she gets married. She has to go here and change it, and they say, well, make sure you go to payroll and change it. Well, make sure you go, wherever you have to go and change your name, and you want to look at them and say, isn't that your job? But of course it wasn't in those. It was your responsibility. So the other thing was when you called to find out if your product was shipped yet, well, you might call marketing if salesmen cover you, if you ordered through a salesman, and they might send you over to production or shipping, or there's a lot of places you're going to have to find out. And of course, the idea was one central repository of information would do away with all those problems. And that's, of course, why databases were invented. One of the problems with changing the databases, of course, is all of these people have their own information, they manage their own destiny, and they're thinking, why should I share? I don't trust those folks. So it was a big step to get over, and it was the job of the systems analyst, and we'll talk about that later, what that job is and what you do, how you manage that kind of change in organization with technology. So we're trying to eliminate redundancy. Redundancy. Trying to get rid of redundancy. That means the data in more than one place, duplicated, redundant. Because we have learned over the years that if the same information is in two places, it's going to be different. And if you're getting reports, giving them to the CEO, and you're giving a different report from a different place to the marketing, department, and the information isn't the same, you have a problem. Is anybody going to trust the data? Of course not. Why is it different? It shouldn't be different. Sales is sales. Well, I use the marketing database for this report, and I use the shipping department for this report. Well, that doesn't hack it with the CEOs anymore. That is not a good thing. So redundancy needs to be reduced. And of course, you want to share the information, which allows you to serve the customer more than you could in the past. Customer can make one phone call, access their customer number on the database, and you can find out where their order is. And the other thing is security. And we can add another one, efficiency. And of course, all these things are handled by the DBMS, the database management system. Efficiency I added there because an expert in the database can make things run better than the filing systems. And it is a science, an art, a skill to make databases run well. Not your Access database so much, but corporate level databases like those at Walmart and so forth. So when we look at data, we know that my name is made up of characters, an R, an O, and a B. These are characters. It's data, but it's made up of characters. Each of those characters is what? A byte. We've learned that already. But if we take 8 bytes, we have a character. If we take a bunch of characters, we have a field. Just the name we came up with, it's just what we call it. It's a field. So a bunch of characters is a field. Okay? Now the data in this field is of a certain type of information. Okay? It can be numbers, it can be letters, it can be numbers and letters, it can be special characters like punctuation. It can be a lot of things. It can be a special format of numbers like phone numbers, social security numbers. It has to have a specific length, doesn't have to have a specific, there's a lot of things you can do with data, and what you want to do is define that. Normally this is done in the data dictionary. Now in Access we don't really do that. We define the data as we create it, which is fine. It works just fine. So the field, data field, always has a type of data and a length of some sort. And you have to specify that. Of course, if you don't specify it, the DBMS will automatically create a length for you and a type, because it has to have one. To store the data, it needs to know what format. We're not going to get into it, but believe it or not, the database actually stores numeric data differently than it stores character data, like text data. So there's different types of data that go into these fields. But the important thing here is something like that is a field that's made up of constituent parts, and they have attributes, mainly type and length. All right? So data is the smallest piece of data you can store in a database is a field. A field has a type of data in it and a length. The other thing I want to mention about a field and good database design is use a descriptive name. Very important. Remember that in your assignments. I'm going to look for that. You want a good name for everything you put in your database. Describe what it does. This would be first name, right? Generally, we break the name into first and last. Why do we do that? So we can sort it by last name. There's always a reason for those things. If we didn't have to sort it by last name, we'd probably put it all in one field, but we do like to sort by last name. Or in some cases, we want to sort by just first name. So we make a choice to split it out. So the perfect name for this would be first name. And we use something called the underscore often. It's the safest special character you can use. The dash could be a minus sign, so you need to be careful with that. So the underscore is the best thing to use when you're separating parts of a name. And I would put it in there. There was a time in my career when we had to worry about field names taking up space on our disk. Memory and storage was so expensive, we used names like FN because it saves space, and we had to worry about that. We don't have to worry about that anymore. Spell it out. So the next person that comes in that might use that data, oh, that's the first name. There's no question. What's FN? Function? I don't know. I'm not sure. Of course, you can look at it and figure it out in this case, but it's just easier if you specify it. So please do that. So we take a bunch of fields, such as and of course, this is a text field. Text field. The length, well, that's a problem with text fields. We usually let the system decide that in terms of access and those kinds of databases. You normally specify a length. You just take what the system has, but let's just say 30. Okay, we have two fields. But I want to keep track of everything about me. So I want to make a record. A record of this person, of me. Well, what else do I want to keep track of in this record of this person? Well, of course, there's things like address. Normally there's an address, line 1, line 2, city, state, zip, phone, date of birth, whatever it is you want to keep track of. For a master record, which is the record everyone's going to access about this person. So you add up all those fields, we get a record. That record keeps track of that person. Now, if we want to retrieve that record, we want to look at that record, we have to have something unique, a unique identifier. Well, couldn't we just take the last name? Well, that obviously won't work. There's an awful lot of Joneses in the world. Once upon a time, there wasn't too many Heplers, but there's quite a few now out there in the United States. Well, it kind of works, but it doesn't work that well. It's not unique. So we have to come up with a unique identifier to make this work. We do that by creating something called keys, or key fields. Each record has a field in it that we call the key. The key allows us to retrieve that record because it has a unique value. People? Wow. Not sure what happened there. Social Security number. Although we talk a lot about identity theft these days, only one person is assigned one Social Security number, so it is unique. There's no such thing as very unique, sort of unique. Unique is one of those words in the English language that has no qualifiers. You hear somebody say that's very unique. That's improper English. Something is either unique, which means it's one of a kind, or it's not one of a kind. There's no in between, there's no very, less, no adjectives there. So it's unique. Unique. We call this unique key primary key. And you probably should define one when we get to creating your database, a primary key. The primary key must be unique. Must be unique. And normally, we index our file by the primary key. We haven't got the file yet, but you can see, you know what that is. We index it, which means we create a way to access it very quickly, okay? And we'll talk about that in a second. There's also things called secondary keys, which allows us to access the records in a different way. Usually they're not unique, although they could be unique. But they're keys. For instance, if I have an automobile in my database, how do I uniquely identify an automobile? By the VIN, the vehicle identification number, similar to a social security number. There's a different one on each vehicle. However, I might want a secondary key, which is manufacturer. So I can pull up all the Chevys, for instance, by just typing in Chevy. That would be a secondary key. And you can also index those if you want. Another type of key I want to mention is the foreign key. That's a field in a record that really has little to do with the information you're storing there, but it allows you to access information in another record somewhere else. And I'll give you an example of this in a second. And of course, you could also index by that. All right. That's fields. Characters are rolled into fields. Fields rolled into records. Records have a key field as part of that record, so you can find what you're looking for, a unique identifier. The next step, if I take a bunch of records, so there's Rob and all Rob's information. There's George, all George's information. There's Ivor, all his information. There's Wendy, all her information. TJ, all his information. There's Bob K, all his information. I take all this stuff, each one of these being a record. Now I have a file. And a file contains records that all are about, they all have a relationship. In other words, they're about the same type of information, but about different entities. Each of these is a different person. But they're all records relating to our customers or our employees. You wouldn't put customers and employees in the same file. You'd put them in separate files in your database. So you could do things with them differently. Okay, so that's a file. If we take a bunch of files, we have a database. That's what a database. A bunch of files which contain a bunch of records, which contain a bunch of fields, all of them related in some way, so they're in the same database. That's where we're going. What kind of files? Well, let's just say we have an employee master file. And notice I used a name there. When I create my file, I give it a good name, employee master. Well, I might also have employee time card. That's to keep track of your hours. How many employee masters am I going to have for each employee? One. How many time cards am I going to have for each employee? Many. We don't know how many. We just say that's a one-to-many relationship. For each employee, there's many time cards. So in the time card records, do you think there's a field called social security number? Of course there is, or employee number, depending on how you do it. Of course, Because when I want to print a check, I need to know what your name is, but I don't want to store your name in every record in the time card file. All I want to store is your employee number or your social security number. I can get the rest of the information here. That way, when you choose to change your name, I can change it here. The next check that prints, your name's changed. The next letter that goes out to you, your name's changed. That's the advantage of the database in more specific terms here. And then we might also have a retirement employee. I'm not going to write this out. Retirement employee reprimands. I don't know. Whatever kind of files and tables you need, you can put them in there, and all of them related. Come up with good names for all of them. Real quickly, I don't want to go into this much detail. Let's say we had 1 million of these, or a meg, 1 meg of records. Remember, each of these is a record. And we have our primary key here. Let's just say it's social security number. I'm just going to put numbers in. And then we have all the data here. And we want to find one specific record. Remember, we've got 1 million of those. I type in a social security number. I want the system, the database management system, to pull out that one record down here at 800,622, 122nd row. Okay? And keep in mind, these might not be in order. They can be in any order. So how do I find that record? With 1 million of them, go to the first one. Is that it? No. Go to the second one. No. Second one. No. 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 And we're talking about a massive. There could be 1 million bytes here on one row. Probably not. But a lot of data could be on one record. So if I want to move that to RAM because it's quick and sort it, I take up a bunch of RAM, and it's a very slow process. So what we do with databases and other file systems, we create what's known as an index. And all that has in it is the primary key followed by the row number. If you want to think about it that way, or the record number. So when we want to search for a specific one, we search the index. That's faster. And the index can be sorted in order. So we can use things, you can look it up, I'm not going to go into it, a binary search. And if things are in order, that works. You can split it in half. Is it greater or smaller? Okay, if it's greater, split the second half in half. And you have to write programs to do that in programming classes. Amazing. 1 million records. I don't remember what the numbers are. Probably 5 or 6 tries you find what you're looking for. Just by splitting things in half till you find it. As long as they're in order. So you can keep this one in any order. And then if this one's sorted, finding a record is much quicker. That's about all I'm going to talk about indexes. If it confuses you or it's just more than you want to hear, that's fine. Just a concept I wanted you to understand in terms of databases. When you build your tables, your files in your database, it will ask you which one's the primary key, or it'll assign a key for you. It has to have a primary key in each file you create. So it's better if you create it than let the system create it. Okay? If you create it, you can find things easier. All right? And we came up with a mechanism so that this 1 million record file doesn't have to be sorted every time you delete or add something. Not a big deal. Put everything at the end, sort just the index. It's quicker, faster, etc. All right. Couple more things. Terms. Field, it can also be known as an attribute. Okay? Kind of synonyms. But a field is an attribute of whatever entity it's describing, right? One of my attributes is my name. And I'm going to use terms that are used in relational databases, and don't worry too much about that in this lecture. We touched on it in the other lecture a little bit. A record, you might hear me call that a row. They're kind of interchangeable. Think about your Excel spreadsheet. There were rows. The columns could be considered what? Fields, right? Record, row, and you'll probably never hear me use this term. I mentioned it in the other lecture. Tuple is a relational database term, but we probably won't be using that. I might use row, though. All right? A file, in database terms, in relational databases, is called a table. And I will use that term because it's what Access uses. Okay, so there's a translation for you. If I use attribute, I mean field. If I use row, I mean record. If I use table, I mean file. Okay? Of course, the next higher one is the database itself. One term for that. Okay. All right. Let's look at Access. And we'll go through some things here. So I'm going to go start. I already have it here. This is Access 2003. If you have 2007, I would ask you to submit your assignment as 2003. It might be easier for me. There's no conversion. You can convert 2007 to 2003 with a plugin, but Access, the database, they haven't come up with one. So it might make it easier if you could submit both. But I'll let you know. Okay, when you open it, there's nothing here. It's just the GUI, right? Application program called Access. Where is it now? It's in RAM. Where was it on disk? Okay, you're tired of that stuff. Access. Well, first thing we have to do, create our database. Well, let's think about that a minute. You just don't create a database. You've got to know what you're going to create, the database, what you're going to do. Your assignment, I leave that open to you. Create whatever kind of database you want. And wanting to keep track of your DVDs, you might do that in Access for this assignment as a start. So what I have to do, File, and you get that drop-down menu, New, and then you get this area over here. By the way, the one that was there before this popped up can be very helpful. That's the online office help. Lots of good stuff out there. What I want to create here is a blank database. Okay? Now, blank database is going to be empty. Nothing in it. No tables, no fields, no records, nothing. That's what I want. It gives you the name DB1 by default, but I'm going to make one for students. Okay? Just call it students. Pretty simple kind of thing. And make sure you put it somewhere where you want it to be. Not going to let me do a touch there, I guess. Okay, there it is. I'm on the desktop. I'm going to put this on my desktop. Create. Now I have something else up there. I know on the recording sometimes the windows here are up before I even talk about them. It makes it a little difficult, but I'm trying to give enough verbal clues so it won't be too big a problem. You should have thought about this on a piece of paper. What do I want to create? And I did. What I want in my database and so forth. First, I'm going to create a table. I'm going to use Design View. You can try the wizard if you want, but the Design View allows us to teach a few more things. Okay. This is the Design View. So what do you see here? Notice I'm creating a table. File, right? And we name it later. So what do I need in here? I need fields. I thought about these earlier. The first field I'm going to call first. No, I don't think so. First name. Data type. Text is okay. And notice when I moved over there, there's a drop down. Those are some of the data types you can use in Access. There's more than that, but those should get you through. Notice there's a memo field. That's just a big blob of information that can grow and shrink as you need it to. Number, you know what that is. Date and time, currency. Auto number means database will create sequential numbers for you. Every time you add a record, it adds another number and puts it in there. Yes, no is just Boolean. True, false, yes, no, however you want to interpret that. OEL is an object outside the database. Object link, OLE, some people call it. It's a link to an object outside the database. Database doesn't have to describe it, you just point to it. It knows where it is. For our stuff, don't worry about it. A hyperlink, that's kind of an interesting one. You could put a web address in there, URL. Okay, but we're going to take test. Always put a description, even if it seems obvious. Notice at the bottom down here, there's a couple other things down here. Field size is 50. I'm just going to leave that. You could change that, make it smaller. Format, you can put in things. Let's look at the drag down here. Nothing in there. Format, you can define things that can come up later. It's like if you want it to be the first letter always capitalized, you can put things in there. Input mask, yeah, same kind of thing. Caption, you can have something and you notice it tells you what it is over here on the right. Label for the field when used on a form. Default value. So you could put Bob in there, or put first name in there as a default value. So if somebody doesn't type something, you get a value. And so forth. You can see there's a lot of things down here. Allow zero length. That means can they leave it blank, essentially. You could say no, which is what it says here. Oh, it says yes, I'm sorry. That means you can leave it blank. I might want to do something else there. Say you must enter something. Is it required? Do I have to put information in there? Index. Is it indexed? No, let's not index it. And so forth. I'm going to go down there. I just realized I made a mistake. So I want to go back up here and say, no, that's not what I want the first field to be. I want it to be social security number. That is not a text field, it's a number field. Change the description. I'm just going to say SSN. Is it indexed? Well, I'm going to come down here to the bottom, do the drag down. I missed it. Indexed. I'm going to say yes, no duplicates. So it's unique. Only one entry in this table can have a value. You can't duplicate that. Okay. So now I'm going to put first name here. I'm going to speed this up a little. I'll just put date of birth in here and make that a date. Okay. That's enough for now. You get the idea. I'm not going to go through a bunch of stuff, but you can put as much as you want in here. Control what's in here down here. Look up down here means you can put something in and tell it to look somewhere else for data. Let's not get into that here. Okay, so I have defined some fields for each record that goes in the table called student. Now all I do is exit, press the X button up here if I can. You want to save the changes? Yes. Notice it used the name table 1, that's the default. It's going to prompt me for it. Student master. Oops, put my caps lock on. Let me redo that. I'm going to call it student master. Okay. There's no primary key defined, it says. Do you want to create a primary key now? Yes. Not sure what happened there. Well, that's not what I wanted to have happen. It assigned a key for me, so we're going to go fix that before I enter data. I highlight my table. I need to fix it. Click on design. Now, I'm going to go up here and click on description here. Right click on description. I'm going to click on primary key, which means ID is no longer primary key. I'm going to go over to the left, highlight that whole row, right click, and delete it. What that was a primary key that the system put in for me, where it would increment that and make each one unique for me. I want SSN to be the key, so I go over here to description, right click, say primary key. Notice over on the left, it put a key there. That's how you modify something you've created. So I'm going to exit again by just clicking on the X. I want to save those changes. Now if I double click on my table, this is a default entry screen. You can build your own. That's called a form if you want to. We're not going to go into it here, but you can do it if you want. Social Security, now I'm going to keep this simple. We didn't say it had to be 9. So first name A, last name AA, just to keep this simple. Date of birth 01/01/01. So we can remember. Okay, it's saying I did something wrong. All right, it's the date of birth. So I'm not sure what it's looking for. Let's see. All right, it must have some format in mind, so I'm going to exit out of here if it'll let me. Gee. It said I couldn't save the data, so I'm going to go back, highlight my table, go into design, take a look at date and time. I'm not sure what the problem is with that field. I would have to do a little research. I'm just going to change that to a number. Keep it simple here. What you're going to have to do if you wanted to do that is go in and just define a format for it, month, day, year or something, and I don't want to get into that right now. So let's do this again. Social Security number 1. But that's called in data integrity. The database was was working on that for me. I'm going to put a 1 there. I'm going to put a 1 there. Tab the first name A, last name AA, date of birth 1, 2, 3, 4, 5, 6. Let's just say that. Okay. Now I'm going to enter another record. I'm going to say 2, 3, BB. Third record. Whoops. This one will be 3. First name C. And I'm just doing this so you can see how it comes up later. We'll be able to remember what we put in here. Okay. I have 3 records in there now. Exit. If I open it this time, the data is still there. Okay. So now I have data in my table. Now, of course, I want to get data out of the table. And I can develop queries. We talked about that in the database lecture. A query is asking a question of the database in which you want data back. So I'm going to create a query by using the wizard. And you can use design and experiment with that if you want. For the purpose of this, I'm going to use the wizard. Let's just say I want every field in there. I can pick and choose. I don't want the social security number to print out on the report, for instance, for security reasons. But for now, I'm going to put everything in there. But you can pick and choose is the point I was making. So I click the double arrow to the right. I click double arrow to the left. It'll remove everything you get. Next. You want a detailed report or summary? Experiment with that. What title do you want? Well, I'll just leave that. It gave me that title, Student Master Query. That's fine for now. Maybe I'll call it Student Master Query. Oops. I don't like wizards. They're too smart. So Student Master Query. One, just in case I'm going to have more than one. All right. So if I finish and I have this box checked, it's going to show me the results of the query. It should. All right, there's the query. Notice it showed it in the same form as it was in the database. You can create forms. You can do a lot of things. We'll go into that in a minute. We'll go into reporting in a minute anyway. So there's a query. Big deal, you say. Well, yeah. It just dumped the data. But queries are valuable. We mentioned in the database lecture. Notice I'm on the query over here on the left. The query is highlighted. So what you see here are queries, not tables. I can look at my tables by going back. I'm on queries. Let's go into the design view. Well, I don't want to create it. I highlight it, click design. All right. This is another way to do queries. This is the same query we just did, only it's with the design view. And notice the fields are checked, which means I want to see them. Criteria. This is what's called query by example. I'm going to put a value in here and say, I only want those records for this query that have the first name of A. Okay. Let's see if this works. Close it. Boy, that's irritating. Save the changes. Let's run the query. Notice all I got were records that had an A in it. Okay, so you can put A and B. You can put greater than C. You can do a lot of things with that query in there. That was by example. You can also put Boolean statements. I'll show you how that works here. Highlight, design. I'm going to take that one out. I'm going to put one in the Social Security number. I'm going to say let's say greater than 1. I only want to see Social Security numbers greater than 1. Save it, run it, just double click it. There it is, all the records in there, all the rows in there with a Social Security number greater than 1. That's a query. All right, you're going to be whizzes here. I think one of the other things you have to do, I'm not going to go into forms, but that's just a way to create a GUI, essentially. If you want people to input only certain forms or fields, you can create a form backed up by a query, and you can do that. But we're going to look at reports. This works just like the query, it just has more stuff built into it. I'm going to create a report by using the wizard. Double click. Notice we only have one table. But I click on that and I can actually choose queries. That's interesting, isn't it? So you can choose a table or a query. It treats them the same way for these purposes. But let's just keep with our, let's use our query. Let's send everything over. Do you want any grouping or levels? Well, you can experiment around with that. It's just a different way to report the data. And you can put priorities and things, but I'm not going to go into that. Do I want to sort it? Well, I'll sort it by last name. I want it to be descending by last name. I can sort it by another field here and so forth. I can keep doing that. Do I want a tabular one or do I want it columnar? or a justified one? Let's see the justified one. Tabular, we've seen enough of that. Let's do that one. Of course, you can do it portrait or landscape. I think I'll do it landscape. Box, adjust the field width, and so there's a lot of things in here. And then it has these built-in ones. You can design your own, but for the purposes of this assignment and what we're doing tonight, we're just going to pick one. But let's see what they look like. There's the bold, casual. I know you're a little ahead or behind me, depending on the recording. Compact. Corporate. Formal. Soft gray. Let's say casual. Just to do something. I always choose something else, so let's try casual this time. Next. Okay, what are you going to call it? Notice there's a title up here. Well, I don't want to call it query. This is a report, so I'm going to change that name. Well, I guess I'll leave query in here. I'll say query report. So I'm reporting on that query is the idea. And it says, do I want to look at it? And I said yes, so let's finish. There it is. Notice it's in descending order by last name. That would be the highest first. Is CC followed by BB. Why are there only 2 records in there? Remember the query? The 3rd record isn't showing because I told it in the query I only wanted those with social security numbers greater than 1. So now I have a query that's always going to run the same way. Now, when I have users who don't understand all this stuff, I can just set it up and tell them to run a query. I can do that with a form. They don't even know they're running a query. But all they see is what that query allows them to see. Powerful stuff. And then you can also have them run the report based on queries, or you can design their own reports, but all they get to see are the queries you let them see and so forth. You get the idea. Okay, that should give you enough. Do your assignment, I do believe. We'll look at it in a second. Now let's look at it now. I want to do a couple more things here, but let's look at the assignment first. Build a database to keep track of something that will be of use to you. Music, video, books, parts. I've had people do training records at work when I was teaching on the bases. Here's the requirements. At least one table. I check. We know how to do that. We know how to build fields. You have to have 3 different data types. We only had 2, text and number. You got to use some other kind. I want you to do at least 5 queries. All right? And I want you to select something at least in one of those queries. In other words, only people with certain last names, only movies directed by John Borman, only movies directed by Ridley Scott. Okay? Something like that. And then 3 reports based on your queries. All right? Remember, one of your queries at least has to have selection in it. Use correct names, name everything well. That's what you do in Access. Then, as always, I want you to create a document in Word explaining your database. Again, assume the person using the database knows how to use Access, understands databases. So what you're doing is just explaining your database. You might define the queries, the reports, what data is in them, that kind of thing, okay? That's it. Upload those 2 files to the portal, and you've done the assignment. This one shouldn't be too difficult. I know if you haven't used Access, there'll be a learning curve, but once you figure it out, and if you follow this recording, you should be okay. If you're having trouble uploading your database, rename it, because the database in 2003 should be your name. Use your name. And Access will create a file called MDB. Okay? Microsoft Database, I think that stands for. Some email services, some, I don't know about our portal. We'll have to find out. May not allow you to upload a database file. If that's true, rename it to .txt, upload it, and I'll rename it when I get it. Okay? 2007, I think, uses ADDD or M. I can't remember. I don't remember. But it uses a different extension. I'd prefer you to use MDB for now. Okay? So that's the assignment. I want to show you one more thing over here that'll kind of wrap up the database stuff and do a little more emphasis on how to do this. I'm going back to tables, so I just clicked on tables. I want to create another table. I'm still going to use the design view. It's what I prefer. Remember, you want to put your primary key first. First. So I'm going to create a social security number, make it a number, and you should have a description. I'm going to just do this quickly. Let's assume I want to keep track of your grades. So you could have more than one grade, right? Okay. So what I'm going to do is put it in here, and we're going to just have something like class, which would be, you know, ST589 or something, and I'm skipping over this stuff. Whoops, misspelled class. Let's go back. I'm going to have grade. I'm going to make that a number. And what I'm going to do in this case, just for the sake of making this simple for you, I'm going to allow the system to assign a key to this file. Okay? But I'm going to come down. So we're just going to exit, actually. And it'll say, do you want to say the change? I'll say yes. What do you want to call it? I'm going to call it student grade. It's going to tell me I don't have a primary key. You want to create a primary key now, that means let the system do it. I'm just going to say yes. Okay, so I have student master, social security number. I have two different tables, files, that share a piece of information. What I want to do now is create a relationship between those two. Do that by clicking on that icon, which is the relationship icon. I'm going to add both files here. And notice over here, it has that ID. That's the one the system generated for me. Now I have this window, and I have my databases. I'm going to touch the student master social security number. I'm going to drag it over to the other one over here. That didn't work. And let go. What I'm saying is link those two tables, or create a relationship is the correct term. And it knows that in the student master, it's a primary key. It knows in the student grade, it's not a primary key because you can have more than one grade. So you're going to need to have a row with your social security number more than once over there, which means it knows it's a one-to-many. One student, many grades. Down here in this box, relationship type. All right, so now I click on create. And it created my link for me. In more update current versions, it shows which is the one in the many with a symbol here. It didn't do that in this case, but that's okay. Now I have a relationship between those two, which means every time I read the student master, it's very easy. It will automatically read the grades for me. That's the idea here. So if I exit out of here, it lets me save it, yes. Now if I create a query, I have two tables I can use now, grade and master. So I'm going to say master, add that table, Grade, add that table. And notice it drew the little line there showing there's a relationship. Now building this query, I'm going to come down here and say, notice now it has for each field table name in front of it. Wonder if I can do that with the mouse here. Student master file. What I want, of course, is their social security number. There. That's the whole record. I'm sorry. There we go. Now, if I have that, I want their first name. Boom. I want their last name. From the master record, because there's no name in the other one, remember? That's enough. Then from the grade record, I come down here a little bit. I don't want their social security number. That would be redundant. What I want to know is what class it was. And I want to know the grade. So now I'm taking data from two different tables that are linked in a relationship. But it's still a query for all that. So I'm going to exit out. You want to save? Of course I do. So I'm going to call this student grade query 01. So let's run that. Why is there nothing in there? Because there's nothing in the grade file, so it can't find anything. So let's put some data in here. Social security number 1. Oh, wait, sorry. I need to go back to tables. Sorry. Grade, now I can enter data. You don't enter anything in the auto number. That system takes care of that. Social security number 1, class, fundamentals. Grade, 98. Social security number 1, concepts, 96. Social security number 3, class, math, 88. Social security number 2, geo, grade, 90. Notice when I put not 7 in here. Class, due time, grade, 91, and so forth. It accepts the 7 because I didn't tell it it couldn't. You could have designed this relationship by saying that you have to have an entry in the master to make this work. I forgot to do that, so it let me do it, but that's okay. It's just a demo. Let's just double check. There's our data. So let's go to queries. Run our grade query. Now we have our information. Why didn't the 7 show up here? Because there was no 7 in the student master. It doesn't show up. You need to have something to do a little better job of editing that so you don't enter wrong data. And you can do that when you just design the relationship and the tables, but we're not going to go into that. All right. Notice there's 2 entries for social security number 1, and you can see what's going on and so forth. So our query is pulling it from 2 tables. That's about all I wanted you to see there, plus the relationship. One more thing, if I go back into design, I can say, give me all the grades less than 98. Save the changes. Now there's only 3 entries in here. The other one for social security number 1 went away because it was a 98. Same concept, all right? I could run a report off of that as well. All right, I think that gives you enough to get started on the assignment. Thanks for listening, and as always, post questions in the open forum, call me, email me, and your assignment's out there in the assignment area, assignment 3. Get to work. I hope you learned something with this Access database. A lot of people haven't used it before, so it's a good assignment for that reason. All right, thank you. See you next time.